Normalize audio, normalize audio. It's going to be unedited, so let me explain. I'm saying normalize audio to normalize the audio so that it doesn't sound weird at the very beginning. Or it sounds weird at the very beginning so that it doesn't sound weird and the intro makes sense. Anyways, how's it going, fellas? So today I'm going to do a video talk through of my calendar system. So, a couple years ago, back in 2020, I made a calendar tracking system of sorts, but it was unfinished and parts of it were incorrect. Back in 2023, I updated it and actually fact-checked stuff to make sure everything was correct, but I never made a video on it. This year, I decided I'm going to make a video on it, and while I was looking through everything, I realized, wait, there's a couple of small stuff I want to add. So the only thing I really added is like the bonus B, but everything else other than that, that's from 2023. So, what is no, okay, you know what? This is the beginning right here, okay? So, also let me mention too, the I don't know why, but the quality is like low. Do you see how like low res this is? Like I don't know what's going on there, but whatever, it is what it is. So this is Extra's updated 2023 calendar reusing and counting system. The basics. A calendar is a chart or series of pages showing the days, weeks, and months of a particular year or giving particular seasonal information, according to the dictionary. Literally, the dictionary definition. For the purposes of this system, a calendar will simply refer to just how the days of the week correspond to the date. The system cannot be used for lunar or extraterrestrial tracking, and also for other calendar systems like the Jewish calendar, whatever, right? This is the Gregorian calendar, okay? Not worrying about other calendars. And literally, again, it's just like day of the week and all that stuff, right? So, here are the universal truths of the Gregorian calendar. Most years are 365 days long, with the exception of a leap year. A leap year happens roughly every 4 years, but not always. A leap year does not happen if the year is divisible by 100, but not 400. If it is divisible by 400, then it is a leap year, despite also being divisible by 100. The only distinguishing factor between any given calendar for any year is what day of the week January 1st lands on, and whether or not it's a leap year. If any two calendars share these same properties, then they are the same calendar. The previous statement means that there are only 14 distinct and unique possible calendar configurations. A majority of the time, the day of the week for January 1st will simply shift by one day. As an example, for 2001, January 1st lands on a Monday, and for 2002, January 1st is on a Tuesday. You see the one-day difference there? This does not always apply thanks to leap years shifting the day of the week twice. So for example, on for 2004, January 1st lands on a Thursday, but in 2005, it's on a Saturday, completely skipping Friday. And that's not even mentioning the years that are divisible by 100 but not 400, but we'll talk about that later. Now that you understand these universal truths, I can show you an intricate system. Redo that part. Now that you understand these universal truths, I can show you an intricate system that allows you to determine what calendar belongs to which year without ever needing to look it up. That's right, every calendar for every year after 1 AD or CE in the Gregorian calendar is right here in this document. Now, I came up with the system entirely by myself back in 2020 and updated it in 2023 just by looking at calendars, doing math, and seeing if I was right, aka constant trial and error. All of the terms, names, and arbitrary dates are simply created by me for the purposes of organizing and understanding what years correspond to what calendars. Oh, and real quick, just to clarify, all ranges in this document are inclusive. So when I say between 1889 and 1899, that is including both the years 1889 and 1899. It's not exclusive. So, in order to learn this new calendar tracking system, you need to learn a couple of new terms. So to start off with, we have a Demos proto-year. Again, I came up with all of these terms completely by myself, except for the ones that are like pretty obviously I didn't come up with it like leap year, right? But first off, we have a Demos proto-year. A Demos proto-year is defined as any year that is divisible by 400. Examples include the year 1600, the year 2000, the year 2800, etc. Now, we have a century set. A century set is a set of 400 years that lasts between 99 years before Deimos Proto-Year and 300 years after Deimos Proto-Year. The current century set for 1901 to 2300 is the 5th century set. The century sets are divided into 3 century groups and 3 outliers. First off, we have the Deimos century group. The Deimos century group is between 99 years before and 99 years after a Deimos proto-year. For the current century set, that would be from 1901 to 2099. Next up, we have the primary Phobos century group. That would be between 101 and 199 years after a Deimos proto-year. For the current century set, that would be from the years 2101 to 2199. And lastly, we have a secondary Phobos century group, which is between 201 and 299 years after a Deimos proto-year. For the current century set, that would be from 2201 to 2299. And also another thing to mention is that there are a couple of numbers you might have missed in between. Well, those numbers that I missed are the century group spacers. Those are the years between the century groups / sets that don't follow the established rules of either century groups or alpha year cycles, and have their own exceptions. These years are also defined as years that are divisible by 100, but not 400. For the current century set, those years would be 2100, 2200, and 2300. You see how those years are divisible by 100, but not divisible by 400? The next term you need to know is a Mars-Moon proto-year, or as I'm going to just refer to it as a proto-year. A proto-year is either a Deimos or Phobos proto-year. So the Deimos proto-year, I mentioned that earlier. Remember, it's a year that is divisible by 400. Super straightforward, super simple. Now we have the Phobos proto-year. A Phobos proto-year is either a primary or a secondary Phobos proto-year. What is a primary Phobos proto-year? Well, that would be any year that is 152 years ahead of or 248 years before a Deimos proto-year. Examples include 1752, 2152, 2552. The fact that it's 2552, which just so happens to be when Halo 3 takes place, pure coincidence. Now, we have a secondary Phobos proto-year. That would be any year that is 248 years ahead of or 152 years before a Deimos year. Examples include 1848, 2248, 2648. Now we have arguably the most important term, an alpha year. An alpha year is either a Deimos alpha year or a Phobos alpha year. Now what is an alpha year? Well, a Deimos alpha year is any year that is 0, 28, 56, or 84 years away from a Deimos proto-year in either direction. So, and there's always 7 per century set. So for the current century set, that would be the years 1916, 1944, 1972, 2000, 2028, 2056, and 2084. A Phobos alpha year is either a primary or secondary Phobos alpha year. For a primary Phobos alpha year, that would be any year that is 0 or 28 years away from a primary Phobos proto-year in either direction. So 3 per century set. For the current century set, that would be the years 2124, 2152, and 2180. Lastly, we have the secondary Phobos alpha year, which is any year that is 0 or 28 years away from a secondary Phobos proto-year in either direction. Just like the primary Phobos alpha year, it's 3 per century set. And those years for the current century set would be the years 2220, 2248, and 2276. Now, what's the point of me mentioning all of these really arbitrary terms? Like, why coming up with the proto-year and the alpha year and all this random junk, right? Does it even make any sense? What's the purpose? What's the logic? Well, dear viewer, let me explain exactly why I came up with it. That would be because of the alpha year cycle. Yes, that is right. There is a cycle every 28 years from an alpha year. So for a 28-year period from an alpha year, there is a continuous cycle of calendars repeating themselves, with the exception of changes to the century group. For example, 2001 is 1 year after an alpha year, the alpha year being 2000, and thus shares the exact same calendar as all other years that are 1 year after an alpha year. That would include the years 1973, 2029, 2153, etc. And not only that, you will also know the year after that is going to also be the exact same as what it was 28 years ago. So this applies to 1 year after, 2 years after, 3 years after. all that in a 28-year cycle, as long as it doesn't cross the boundaries between century groups. We'll get to that in a bit. And I mentioned right here, however, as alluded to before, the cycle breaks every time we approach a century group spacer, like the years 1900, 2100, and 2200, and 2300. Those are all years that whenever you get to that point, that's when the alpha year cycle breaks. So the jump from one century group to another is a very specific event within the alpha year cycle. For specifically the century group spacer, the cycle will jump back 6 years. But for the next year, the cycle will jump back another 6 years. For example, the year 2099 uses the same calendar as any year 13 years away from an alpha year. But the year 2100 uses the same calendar as any year 12, because you subtract 1 because it's the year after, 12 plus 6, or 18 years away from an alpha year. And then the following year, 2101, uses the same calendar as any year 17, again, it would be 18, but you subtract 1 because it's the next year, 17 plus 6, or 23 years away from an alpha year. Also, if it were to overflow past 28 years, it would simply wrap back to 0, right? So, like, if you were to take it, like, 24, for example, 24 years away from an alpha year, and you add 6, and it would obviously overflow, so it would go back to being, like, 4 years away from an alpha year or whatever, right? Okay, cool. Then it continues like normal from there. So with 2101, it would be 22 years away, and then 2103 would be 21 years away, and so on and so forth. So it's just that alpha year, it's just that century group spacer that breaks the connection, but right after that connection breaks, it goes right back into the same cycle. So here's a table showing the distance to and from an alpha year represented by D, whether or not it's a leap year represented by L, and the day of the week for January 1st represented by W. As mentioned at the beginning, any 2 years that start on the same day of the week and share the same leap year property, either both yes or both no, will have the same calendar. So let's take a look. So right here we have the alpha year, which is yes Saturday. So yeah, the year 2000, that would be yes Saturday. That means it was a leap year, and the day of the week for January 1st was Saturday. Alpha year plus 1, no Monday. Alpha year plus 2, no Tuesday. You see how it changes by 1, it goes Saturday. Skipping Sunday, sorry. Monday, Tuesday, Wednesday, Thursday, but it's a leap year. So we skip Friday and we go straight to Saturday. Sunday, Monday, Tuesday. It's a leap year though, so we skip Wednesday, go straight to Thursday, Friday, Saturday, Sunday. Because it's a leap year, we skip Monday and go straight to Tuesday. So let's take a look at the current year, right? We're currently in the year 2024. 2024 is a leap year, and again, it's a alpha year plus 24 or alpha year minus 4. So you could consider it such that we are either 24 years after an alpha year, or we are 4 years until an alpha year, because the next alpha year is in the year 2028, which is coming up in 4 years. And as you can see right here, it is indeed a leap year, and the day of the week for January 1st is Monday. Go ahead, check your calendars. It is. So there you go. And like I said, it just keeps going on that cycle. And you see right here, right? You see how this is no Friday? You see how this is no Friday, alpha year plus 27? Well, you know what's after Friday? Saturday. Saturday. And guess what? The cycle continues. So you can start to see what I'm getting at. AKA the year 2000, right? 2000, which is either 2000 plus 1 or 2028 minus 27, is the same as, it's going to have the exact same calendar as the year 2029. Right. Now we have it all grouped by repeat. So for no Sunday, you have plus 6, plus 17, plus 23, aka minus 22, minus 11, minus 5, okay? And you can see there's a difference between the two. You basically take the difference of 28 in between them, right? So 23 plus 5 is 28. 17 plus 11 is 28, right? So that's where you get those numbers from. So those are all for no Sunday, no Monday, no Tuesday. Now, those are all the non-leap years, and here we have all of the leap years. Yes, Sunday. Yes, Monday. Yes, Tuesday. Yes, Thursday. So what you might have immediately noticed is that we only have within the 28-year cycle, we only have one day of the week corresponding to one leap year. As in, if you're on a leap year, and like for example, Monday, yes, Monday, which is 24 years after a leap year, you notice how that's the only one, right? We won't get another calendar that's exactly like the one we have right now until another 24 years or 28 years from now when the cycle repeats itself and we are again 24 years after an alpha year or 4 years before an alpha year. So, yeah. Now there is interesting stuff I will mention later, but yeah, we if you have a calendar for 2028, you won't be able to reuse it in its entirety for another 28 years. Now, we're going to talk about the bonus, right? So this is bonus A. For any given year, you can determine what the next and most previous reusable calendar is. If that year is 1 year after a leap year or 3 years before a leap year, the most previous reusable calendar was 11 years ago, and the next reusable calendar is 6 years ahead. For example, for the year 2021, you subtract 11 years because it's 11 years ago, and you get the year 2010. For the year 2021 again, you add 6 years, and the next reusable calendar will be in 2027, or at least, or you will be able to reuse that calendar for the year 2027, and that is the least amount of time you'll have to wait to reuse the calendar for 2021. That's what I'm trying to say. If that year is 1 year before a leap year or 3 years after a leap year, the most previous reusable calendar was 6 years ago, and the next reusable calendar is 11 years ahead. Example, 2023. You subtract 6 years, 2017. That was the most previous reusable calendar. However, if you want to go in the future, 2023 plus 11, 2034. If that year is 2 years ahead of, or sorry, redo. If that year is 2 years before or after a leap year, the most previous reusable calendar and next reusable calendar are both 11 years ago and ahead. There's no difference. It's 11 years either way. So for the example, the year 2022, the most previous reusable calendar was in 2011, and the next reusable calendar will be in 2033. So if that year is a leap year, the most previous and next reusable calendar are 28 years ago and ahead. And I just mentioned this, so for the year 2024, you add 28 years, you won't be able to reuse the calendar that we have right now until the year 2052. And also, 28 years ago, which was what, 1996, right? I'm pretty sure. That was the most recent time that you would have been able to reuse this calendar. Now, everything I said is true, to a certain extent, but I technically lied to you because these rules only apply if the century group doesn't change after adding or subtracting. If it does, it's a lot more complicated, but don't worry, I figured it all out for you. So, if that year is a century group spacer, the most previous and next reusable calendars are 6 years ago and ahead. So, for example, the year 1900, the most previous reusable calendar was 1894, and the next one was 1906. For years that are not a leap year or century group spacer, if that year is 3 years after a leap year and or 1 year before a leap year, the most previous reusable calendar was 12 years ago and the next one is 6 years ahead. So for example, the year 1895, it goes over to the 1900 mark, right? So it passes and it changes into century groups. So you go 1895 plus 6, year 1901. 1899, you add 6, you get the year 1905. 1903, you subtract 12 because you're passing that 1900 threshold, you're changing century groups. But since you're going backwards, you're subtracting 12. The most previous reusable calendar was 1891. If that year is 1 year after a leap year and or 3 years before a leap year, same difference. But, it might not be because of the fact that the century group spacer isn't a leap year, that's why I say and or. The most previous reusable calendar was 6 years ago, and the next reusable calendar is 12 years ahead. So literally the exact opposite, right? Because the property of whether or not it's 1 year after a leap year or 3 years after a leap year is flipped, whether or not it's 6 years ago or ahead or 12 years ago or ahead is completely flipped. So 1897 plus 12, 1901 minus 6, 1905 minus 6. If that year is 6 years before and or after a century group spacer, add or subtract 6 years. For example, the year 2106, that's exactly 6 years after a century group spacer, so the previous reusable calendar was that century group spacer. For the year 2094, it's 6 years until the century group spacer, so it is exactly the century group spacer. Now for leap years, boy, does it get complicated. Okay, so first you have to look at the current distance to the next century. Again, this only applies when changing from one century group to another. If your year is between XX89, aka 11 years before the new century, and XX99, aka 1 year before the new century, you simply add 12. Examples, the year 1892. That is between the years 1889 and the years 1899, so you have to add 12. The next reusable calendar for 1892 is in 1904. For 1896, again, it's within that threshold. You add 12, you get 1908. And this is the exact same thing, but it's the opposite. If it's between 1 year after and 11 years after the century and you're subtracting, then you subtract 12. So 2304, if you're trying to subtract, you subtract by 12 rather than 28, right? Same with 2108, you subtract by 12, you get 2096. If your year is between XX72, aka 28 years before the next century, and XX88, aka 12 years before the next century, you simply add 40. 40. So remember, if it's before 28 or before 11 years before, or sorry, no, that's right. If it's If it's after 11 years before, you add 12. If it's before 11 years before, aka 12 years before, then you add 40. So there is a difference there. So for the year 1880, you add 40, you get the year 1920. For the year 2176, you add 40 and you get 2216. So you can't add 28, you can't add 12, you have to add exactly 40. And I might try and show an example in a bit. It's going to be hard to do it, but I'll try. And then 2284 plus 40, 2324. Okay, cool. And this is like literally the exact same thing, but in reverse. If it's 12 years after and 28 years after, you subtract 40, right? The exact same thing, but in reverse. And here's just a little bonus thing right here. The century group spacers, day of the week for January 1st. For 1900, it's a Monday, not a leap year. For the year 2100, it's a Friday, not a leap year. And for 2200, it's Wednesday, not a leap year, okay? And also, this applies to anything that's Deimos proto-year minus 100, or Deimos proto-year plus 100, or Deimos proto-year plus 200, respectively. So that was bonus A. Here is bonus B. This is a very interesting one. Leap years, and this is exactly, I added this like a couple days ago. This is the only thing I added. Everything else I made back in 2023, or I updated it in 2023. I added this a couple of days ago. Leap years also share elements of non-leap year calendars, with the only significant difference being February 29th. Considering this, the following logic applies. If you have a leap year that is on a Sunday, where January 1st lands on a Sunday, then it's the exact same as a calendar where it's not a leap year and it starts January 1st is on a Sunday up until February 28th. But after February 28th, it is obviously you have February 29th, which is the day after, and then it switches to a calendar where January 1st is on a Monday and it's not a leap year all the way from March 1st until the rest of the year. So it's a combination of two different calendars. It's no Sunday from January 1st to February 28th, but then it's no Monday from March 1st to December 31st. And that applies to every single one here, right? It's the same as the no version for up until February 28th, but after that, it's the day after, because again, you have that February 29th that shifts how many days there are in the year and all that good stuff. So, technically, you would only actually need 7 calendars, all without leap years, but add a grayed out February 29th with a disclaimer that if your current year is a leap year, that you need to switch to a different calendar, one where the day of the week for January 1st starts at a day later, typically, but not always, 5 years previously, than the one for the current year. So, for example, for the year 2024, although the most recent reusable calendar was way back in 1996, you could technically use a calendar for 2018, 6 years ago, up until February 28th. And then you switch to a calendar from 2019, 5 years ago, for the rest of the year. So there you go. That's your fun little fact. If you don't have a 2024 calendar, well, if you have both a 2018 and a 2019 calendar, then you're covered for the entire year. Moving on, moving on. Here's a chart for the 5th and current century set, with the first number representing the distance to the next alpha year. Positive number means distance from most previous alpha year for clarification, because sometimes the numbers, it just makes more sense to write it like that. But only during the century group transitions. For the years from 1901 to 2300, because like I said, that is the current century set. So remember, the current century set repeats every 400 years. So for any years before 1901 or any years after 2300, you simply add or subtract any multiple of 400 until you get to one of these values. For example, if you're trying to find out, let's say 2552 or whatever, right? Well, 2552 is after 2300, but if you simply subtract 400 from 2552, you would find out that it is 2152. And then you just use the value here for 2150 as an example, right? So here is the Deimos century group. Starting off, we have negative 15, that is 15 years until a leap year, and it is until an alpha year, and it is a no Tuesday. Then it keeps on that trend until it gets to 1916. Then it resets, negative 27, and it goes all the way down until, you guessed it, 1944, where we get our next leap year or alpha year. And then it continues on until we get to 1972, and then it goes all the way until the year 2000. So again, all of these alpha years, they all are yes Saturday, right? And the day before is always a no Friday. You can look this up to verify for yourself, but you can see this is the cycle, right? This is the way that the cycle works. And then you get to the year 2000, yes Saturday, and if you move on here, all the way to the year 2028, where it is also a yes Saturday. And it can keep going, It's nothing too crazy here. Oh, wait, what's this? Why am I clarifying that it's +1? Well, I think you already can tell why. It is because we are approaching a century group spacer. So once we get to the year 2099, we are at the same as any calendar that is negative 13. AKA, it is 13 years away from a alpha year. So no Thursday, negative 13. Let's show you as an example, right? Negative 13, no Thursday, right? So it's the same as this calendar right here, and it would be a yes Friday. This would be what the next year is. However, because of the way the Gregorian calendar works, we jump up in the cycle. So now it is negative 18. So right here, you see how we jump? We jump up to negative 18, and it's also a no Friday. So we're going back to 10 years after an alpha year. But as I mentioned earlier, that changes again when we get to the next year. Now we're 23 away. You see here, negative 18. You add 6 years, and then because it's the next year, it would technically be adding 5 years. Now, 18 plus 5, 23, negative 23, no Saturday. But as you can see, that adds up, right? This is no Saturday, this is no Sunday, this is no Monday, this is no Tuesday. And it continues from that cycle right here until we get to 2124, where it is a yes Saturday. And again, this is all stuff that you can find out for yourself, and it should theoretically make sense to you, because again, normally it shifts by every year, right? So no Thursday, no Friday, no Saturday, no Sunday, no Monday, yes Tuesday. Again, it has to flip because there is a 4-year gap, or there's a gap where there's supposed to be a leap year, but there isn't. So obviously it has to go somewhere else in the cycle. But it can still continue on itself in the cycle. It just has to go further back in the cycle. Until we get again to the year 2124. It moves on and moves on. 2152, yes Saturday again, because it is an alpha year. 2180. But 2180, again, we're approaching the alpha year, or the century group spacer. So We're at -9 right here, no Tuesday. -14, it bumps up by 5. Again, you add 5, technically, you're adding 6, and then it's the next year, but for the purposes of this, you're adding 5. No Wednesday right here, it's the same thing. And again, that should make sense to you because it's no Tuesday, no Wednesday, because it's the day after, and then no Thursday, because again, it's the day after. And we are going all the way back to -19 in this cycle. So we go from -9, add 5, or subtract 5 technically, -14, another 5 years, -19. We are back on track for a no Thursday. Continue that all the way until the year 2220. Go here, 2248. Go here, 2276. Again, we're approaching a century group spacer. You get to -5, same as +23, no Sunday, -5, you add 5, no Monday, right? 18, and then another 5 years, -15, 2301, no Tuesday, again. No Sunday, no Monday, no Tuesday, and then we're right back where we started at the beginning of a new century group. No, new century set, right? Because we went past our century group. This is the very last year of this century set. Now we're both in a new century group and a century set, and we're at 2301, 15 years away, until we get to 2316, yes, Saturday, and again, that's basically where we started, 1916. Remember, 1916 was right here, -15, all the way here, 1916, yes, Saturday. Pretty cool, huh? Isn't that neat? You have every calendar for every year after the year 1 AD right here in this document. All you need to do is just either look up or know what your next calendar is going to be, and then you can just go ahead and look it up. Again, this only applies to days of the week corresponding to the date, like January 1st landing on a Monday or whatever, right? And again, this is all stuff that you can look up and verify for yourself if you wish. So if you don't believe me, for example, you're like, I don't believe you that the year 2056 is a yes Saturday. Okay, well, let's go ahead and look it up. Calendar 365, that's the website I like to use. 2056 images. And look at that. It is indeed a leap year because there is a February 29th, and January 1st starts on a Saturday because that is how every single alpha year starts. So, there you have it. You have all of the information you need to put yourself forth and reuse calendars to your heart's content. Very neat, very, very neat. I hope you guys enjoyed this little explanation video, and I hope you guys take care. Peace. Bye-bye.